Okay, good evening all. Can you hear us?
Yes, sir. Good evening, sir. Yes, sir.
Good evening. Good evening. So, yeah, there are questions that have come in before for the live session. Maybe we'll take these first, and then we'll come to the questions that people want to ask in the session. First question is mats and pads for earth reinforcement. Oh, I guess you...
It's a different question. It's not a technical question.
Oh, Chirag, you're there. Can you ask?
Yeah, it's better if you are asked. You
Yeah.
can ask directly, Chirag.
Chirag, if you want to let us know what this question is about, mats and pads for earth reinforcement. Chirag Kumar, are you there?
No.
Okay, anyways, we'll move to the next.
So actually that question is not clear. So you can ask the question again if you have more doubts.
There's a question from Tangavel. Tangavel, are you there?
Hello.
Yeah, Chirag, yeah, go ahead.
Yes, sir. Yes, sir.
You had
Yes,
the
sir.
question
So I'm
about
in third
mats
semester.
and pads.
Yes, sir. Yes, sir.
What is the question? I mean, what exactly do you want to know?
So it is a topic on. Yes, sir.
No. You have asked here mats and pads for earth reinforcement. I'm not sure what exactly you mean from that. Hello? Are you there, Chirag?
Yes, sir. Yes, sir. So it is a topic on building materials. I am in third semester.
Okay.
Yes, of modern materials, and there is a topic I don't know that is pads and material for earth reinforcement.
But what is your question?
Oh, you want to know what materials?
Yes, sir. Yes, sir. Yes, sir. What are the mats and pads that are used in the reinforcement of earth reinforcement?
See, I'm not sure about mats and pads. Generally, we use for giving a higher, for increasing the stability and all that. We use things like geotextiles
Yes,
and
yes,
so
sir.
on.
Strips also.
Yeah, we also use textile strips basically.
Okay.
But mats and pads, I'm not very
Yes,
sure.
sir.
Mat, I guess you mean geotextile mats, right?
Okay, sir. Okay.
So that's a little bit of a slightly higher level subject, which
Okay.
we deal with probably when you come to geotechnical engineering. You are in third semester, you said?
Yes, sir. Yeah, from Himachal Pradesh HPTU.
Okay.
Yes, sir.
So when you come across the subject in geotechnical engineering, you'll probably have a lot more to deal with that.
Yes, so they have added in third semester.
Yeah.
Yes, sir.
It's mainly to increase the lateral stiffness. You don't allow soil to move sideways.
Yeah.
Some kind of reinforcement in that direction.
Yes.
Yeah.
And I think you had one more question, Chirag, about the materials
Yes,
used in 3D printing construction, whether
Yes,
OPC
sir.
cement is used.
Or another.
Yeah. So
Yes.
see, again, you can use different type of cementitious materials for 3D printing. OPC obviously is OPC based systems are obviously in use. There are a lot of people using ordinary Portland cement based systems.
Yes,
You
sir.
could also use other types of cements. You could use even non-cementitious materials like what we call as alkali activated materials, which do not have any cement. So it all depends on the kind of mix that you actually make, whether it has the property of being able to be printed in layers without deformation and also develop the right level of strength.
So are there admixture added in 3D
Of course, yes,
construction?
yes.
Or okay.
Yes, with most concretes that require special characteristics, you will need to add specific additives. So in 3D printing, you add what is known as super plasticizer, and you also add typically something to control the viscosity.
Okay.
Like you must have worked with clay for as a kid, you must have worked with clay, right? So you have to add
Yes.
the right amount of water in clay so that it possesses a certain characteristic called plasticity, and then you can lay the clay out in several shapes and sizes. No? It has to maintain its shape without cracking. The same kind of concept we apply to actually design 3D printed materials also.
So are there books to, sir, further study the 3D
See, 3D
construction?
printing is fairly new with respect to its application in engineering. So
Yes.
you may not find any textbooks which are referring to 3D printing. There's of course a lot of research papers. Now there are tons of sites showing you videos as to how 3D printed concrete is made, how it is applied, what kind of instruments are used, and so on. So you'll probably get much more information there. It may take some time for books to carry information in 3D printing.
Yes, sir. Yes. Okay. Sir. Thank you, sir.
Thank you. There's a question from Tangavel also that came in regarding hollow concrete block masonry. As per the lecture, the blocks are laid by facing cavities upwards. In few places, he has seen people laying the blocks reverse by facing the plane surface top. Now, issue is in a cavity block or a hollow block masonry, the cavity is through and through. It goes through the depth of the material, through the depth of the block. So whether you lay it one way or the other way, it doesn't matter. The cavities are always aligned in the vertical direction. So that helps you later to put reinforcement and so on. So you'll not have, you'll not be laying it in the other direction because
it's the wrong thing. I don't know where
yeah.
it's be.
I know why somebody has done that, because if you're laying in the wrong direction, obviously you can see through the cavities into the building. You don't want that to happen, right?
No, I think he's probably meaning that in the, I mean, are you there?
Tangavel?
Tangavel, are you there?
Tangavel is not there probably. Yeah.
Maybe you are not really talking about the hollow concrete block.
Yeah.
Maybe
Possibly.
something else.
It may have been a solid block also.
Yeah.
What you saw. Anyway, I think that's all the questions that actually came in. Now feel free to interact and ask questions here because we don't really have other questions. Anupama, were there any questions which came on the forum that need to be answered here?
Yes, sir. I'll forward them. Most of them are answered.
Okay.
I'll forward. Sir.
You can even
just,
put it in the chat box
yeah.
if you want.
Yes, sir.
Yeah, the others, you can unmute and speak. You
Yes,
don't
sir.
have to ask. Yeah, go ahead.
Sir, actually, I have a question, sir. Like, as you said, sir, like, hollow blocks, sir. I have seen like some solid blocks also, sir. Like they made it on the side itself, sir. So, like,
Okay.
which will be better, sir? Like, for if we take about the strength, sir, like stability, sir, which will be better, like, for using the red brick or that blocks, sir, like that concrete brick, sir, that is made on the side itself, sir. Which one is better for like strength purpose, sir?
Okay, so the thing is with concrete blocks, you can make it to whatever strength you want, right? You can design the concrete to achieve the strength that you want. Between solid blocks and hollow blocks, the solid blocks obviously will be stronger, but the hollow blocks carry the advantage of being lighter in weight. And they also give you the potential to put reinforcement inside for reinforced masonry structures. Red brick, of course, aesthetically, people sometimes prefer red brick, but then you have to realize that you're using topsoil for producing red bricks, so it's not environmentally a good thing to do. Concrete blocks, on the other hand, can be stronger and have less water absorption as compared to red brick. So it's a good idea to have concrete blocks replacing red bricks. And then again, we saw in the lecture, you might have seen the sizes, right? For every 8 bricks that you use, you can actually use 1 block. So your productivity is also going to go up when you're using blocks, especially when you start using the lightweight blocks, especially when you don't have load-bearing walls. Lightweight blocks can really cut down your the time significantly and make your construction much more productive.
And also about the thermal, comfort or exchange of heat from outside to inside will be much less. Those kind of advantages are also there, and also noise control.
Correct.
Insulation.
Sir, actually, another question, sir. Like I have seen in my own hometown, sir. Like I have seen like they use outside, from outside they use the concrete block, sir, and from inside they use the clay block, sir. Clay block they make, sir, actually in my own hometown because for the temperature purpose, sir.
Correct. Correct. Clay is, clay-based materials are known to be much better in terms of reduction in heat flow into the buildings. They are poor conductors of heat, so they can keep the heat out of the building. So a lot of people do seem to prefer clay bricks and clay blocks to keep the heat out. Yeah. And of course, you're also utilizing at the same time the strength that can be given by the concrete blocks.
Yeah, so there is also a question from Akhil. Can a fracture happen due to tension on material or impurities only, or it can be due to temperature on weather conditions? Or weather conditions, yeah. So yeah, definitely, you need to have a tension force for the fracture to happen. But if you are talking about impurities, that will lead to crack initiation. Wherever you have some kind of deformation or change in the geometry, that will lead to the point where crack can initiate, like a crack initiation point. And if you're talking about temperature or weather conditions, so that itself will not lead to cracking, but temperature or changes in temperature conditions can probably generate some stress within the material, which will then localize and then create crack initiation. Okay, so is that clear, Akhil?
I don't know if Akhil is there.
Akhil is there?
Probably not. No.
Okay. Okay, Anupama posted it. Okay.
Yeah.
Okay. Besides white patches, is there any issue with efflorescence, reducing the strength of the wall or leading to corrosion, etc. of fittings?
No, efflorescence is basically a problem with the aesthetics. So it's not really going to affect your strength of the wall. No. And it may not, it will not lead to corrosion because you are removing the salt. Salt is actually coming out of the building. Is there some rule on what thickness the mortar joint should be in a wall to make the mortar weaker than the masonry? Well, not so. Generally, you prefer. See, mortar is weaker than masonry. Okay, so you prefer generally a thin jointed wall because what will happen is if you make a very thick jointed wall, you have a larger area of the weaker material. So again, possibilities of defects and failures.
Long-term deformation.
Long-term deformation also will be more. Yeah. So you want to keep the joints as thin as possible. So that's essentially the way to look at it. And of course, thinner joints also make the structure look a lot more aesthetically pleasing. Yeah.
So thinner doesn't mean it will be weaker. I think that's the doubt. Is there some rule on what thickness the mortar joint should be in a wall to make the mortar weaker than the mesh? So thickness is not going to control.
No, I think I had said in class that because mortar is weaker, you generally prefer thin jointed walls so that the wall strength is improved. But if there's some rule on what thickness the mortar should be, well, I am not really aware of it, but if I come across this, I'll let you know. Yeah, I'm not sure about the rule that is followed in this case. I'm sure that in masonry design, there may be some thumb rules at least, if not scientific rules that are being followed. But typical mortar joint thickness is 1 centimeter or less. But when you go for thin jointed mortars, it could be much lower than that. Maybe, for instance, when you're going with autoclaved aerated masonry blocks, the general practice is to use even 3 millimeters as the joint thickness. Only problem there is obviously you need to control your sand size because 3 millimeters means you can't go with the regular sand size. You have to use much finer sand. And there are other issues associated with that.
And also the shape of the block should be
yes, proper.
Proper. Otherwise, you won't get proper leveling.
Yeah, yeah. If you have a proper wire cut brick, it'll have a proper shape. But if you have the handmade bricks, those have very poor dimensional tolerance, because of which you'll probably have uneven depth of mortar in each layer.
Sir, excuse me, sir.
Yeah, go ahead.
I have a question, sir. Like at some times, sir, as we make the column of the building, sir, actually at one stage, sir, it is okay, sir. But after the we make the column, sir, after each floor, sir, we attach it after each floor, sir. And after some time, we see that it's not totally straight, sir. Sometimes it gets a little bit tilted, sir. You tell me. So it will affect the building, sir, in the long term or not, sir?
Certainly, it will definitely affect your building, and that's because of poor quality assessment at the
It
site.
depends on how much tilting is there.
Yeah, of course.
Not much, sir. Actually, if I have seen, sir, like if I compare, sir, like the both the, sir, like if I compare a parallel, sir, like parallel to column, sir, one is little bit swings a little bit tilted, little bit tilted, it's swings, sir. So like from not from the bottom, sir, it's seeing to tilted from the upside, sir. Like as it is going upside, it is getting a little tilted, sir. So I have a question, sir, like it will affect the building, sir, it will or not, sir, like settlement happen or not in the building, sir, in the long term, sir, like.
See, your load paths are changing a little bit when you are going out of plumb. You've not designed your building to take those kinds of loads. But see, in many cases, our factors of safety are so high that these things generally don't tend to affect the overall capacity of the building.
But you don't want to tell this to
Yeah.
everybody.
Yeah. Yeah, it's basically poor engineering on site, which
Yeah.
causes it to happen. So, but yeah, we don't want to tell this to the engineers on site or foremen on site, because they'll think that we are saying it's okay to do it like
Yeah.
that. It's not okay to do it like that.
And also maybe the tilting which you're saying, are you talking just the concrete surface or after plastering?
Just a concrete surface, sir, not after plastering, sir. Not
Yeah.
after, yes, sir.
After plastering, they'll level it up, right?
Yes, sir, yes, sir.
Yeah. See, these all becomes very important when you talk about very tall structures also.
Yeah,
If you're talking about 1 story, 2 story, may not be much of a,
correct.
it won't lead to collapse or anything.
Yeah.
But if you're talking about multi-story buildings, definitely they are important. Because if every column start tilting after some floors, you will see, significant inclination, right? The whole structure will look like swayed to one side. So that may not be good. I think,
Sir,
Yeah.
sir, like similarly, sir, like in the colder region, sir, what should be the better option to use inside, sir? Like what brick should be the better option, sir? Like to make that the temperature, to maintain the temperature in the room, sir. Like in winter, sir, it's like too cold, so we have to maintain the temperature, sir. We can't use concrete everywhere, sir, because it's like it gets too much cold, sir. So like they use some timber also, sir, in the roof, sir. Like, so what type of brick should be used, sir? Like they normally use the, like some people use totally in the building, sir, they use that clay brick, sir. They use whole building clay brick, so it's not visible, sir. Like in the rainy season, sir, it gets totally washed off, sir. So it is like a risk type. So what should be used, sir?
Well, see, from the point of view of keeping the heat out, the clay bricks are very good. But
he's telling on the
you're talking about cold regions.
Cold region.
In cold climates, the wooden paneling is usually good because that helps to keep the interior warm. Again, I guess when you have a cold climate, you have to get as much heat retained in the building as possible. So even there, if you have a heating system, a wall that does not conduct the heat easily is always more preferred. So brick-based systems will definitely be useful there also, right? Just the same way that they don't allow heat to come inside, they'll not allow heat to go outside also. So they will be able to maintain a better temperature difference as compared to a solid concrete wall, for instance. Solid concrete wall may not be as effective as a brick.
Yeah, I think you have to look at this thermal conductivity of that material
and design it for that particular environment. Now, of course, there's a lot of interesting things coming up with respect to heating of buildings or keeping buildings warm. There are what are known as phase change materials, which are able to absorb energy and store heat and dissipate it during the cold temperature seasons. So those are, of course, going to add to the cost. But then, yeah, there are solutions like that available.
Which region you were talking about, Mumtaz?
I am talking about Ladakh, sir. Actually, I belong to Ladakh, sir. That's why I'm talking about it.
Yeah.
Oh, you're from Ladakh, okay.
Yes, sir. Yes, sir.
Yeah, so I think the idea is use something which will, reduce the thermal conductivity of the material. So the more air you have inside the brick, it will be better.
Yeah.
But not large air voids, but then you will have issues with the strength.
Yeah.
But you have to optimize so that strength is not significantly reduced. At the same time, you have good enough quantity of air so that heat exchange will be less. I think Ladakh, there was one video. I forgot what was it. They used some straw or something, no?
Yes, sir. Yes, sir.
Okay.
To reduce it, right? Correct?
Yes, sir. Yes, sir. Actually,
Yeah.
sir, what they do, sir, like in the bricks, sir, in the clay bricks, sir, they add some straw, sir. I don't know why,
Okay.
sir. Like in my on my own houses, I have seen, sir, there's some straw in the clay, sir. They mixture, sir. They mix some
Yes.
straw, and after that, they prepare the bricks, sir. Actually, like in 2 to 3 days, it gets set over there, sir. And after that, they use it in the construction site, sir.
Yes.
Yeah.
So locally available material,
Yeah.
So that may also help in preventing the cracking of the bricks.
That's probably the primary purpose.
Yes.
Prevention of cracking is primarily important. See, earlier you said during the wet season, there's a lot of wash off of the material. That may happen because the bricks are probably not burnt properly. The bricks have to be burnt at the right temperature. When you have underburnt bricks, they'll have very poor resistance to moisture.
In fact, I remember, like, earlier time, nowadays we do construction, everything need to be done very fast, right?
Yeah.
Earlier people used to make the brick wall and then leave it for one rainy season.
Correct. Before, yeah.
Before plastering. So you will know which brick is bad and which brick is good. So now we don't wait. We, fast-paced construction. So there are always disadvantages of that. So how do we have to overcome those things? By testing properly. Testing the material, representative materials, for various properties. Yeah. Tushar, you are asking something?
Actually, sir.
Yeah, go ahead.
Actually, sir, they don't burn the bricks, sir. Actually, they just make them bricks, sir, and just they keep there, sir, for 2 to 3 days. After that, when the brick gets set, sir, like it can take some load. After that, they use in the construction site, sir, directly.
Yeah, but they will have a good roofing system so that rainwater doesn't reach the bricks in such cases.
Yeah, you'll need to then devise engineering solutions to ensure that water does not come into the contact with the bricks, because these are sun-dried bricks. They'll have some strength, but they'll not be able to withstand moisture easily. So sun-dried bricks are possible, but if you need good strength, you have to burn and better water absorption resistance. You'll probably need to burn it at the right temperature. I think Bhavesh had a question. Bhavesh, you had unmuted earlier. Tridev, any question from your side? Hitesh? No? Maybe they're just joining at that time. Yeah, feel free to ask any question. Don't be shy.
Can you explain why arches and domes experience compressive forces only?
Okay. Yeah,
bending moment. Bending moment.
Well, that's the nature of the shape. Yeah. No? So what happens is when you have a load coming on top of these arches and domes, the load path basically is going all along the arch shape. So parabolic or segmental or semicircular shape, whatever it may be, the force is basically, the load path is in such a way that they are transferred all along the arch itself. They are not, there's no load acting in a transverse direction. So because of that, when you have arch units which are sitting next to each other, they can transmit the load from one to the other by simple compression. That's the reason why you have mainly compressive action in arches and in domes.
So you can also look at the bending moment diagram and shape of that bending moment diagram.
Exactly. So when
So
you have
that
a
will-
flat beam versus an arch, you can compare the bending moment diagram if you have a uniformly distributed load on top.
Where the latex modified bitumen is used.
My God, where did we talk about latex modified bitumen?
We got from somewhere else.
Chirag, you're there. You can ask this question. I'm not.
Yes, sir. Yes, sir.
Yeah. Latex
Yes,
modified bitumen.
Yes, sir.
So there is polymer modified bitumen that is used for road construction, but we have not come to that
Okay.
chapter yet. So I'm surprised you're asking this question so soon. But yes, polymer
sir.
modified bitumen is available these days. A lot of alternative bituminous materials are being used to increase the resistance of the pavement to problems like rutting, raveling, and so on. So polymer modified bitumen is used. Yeah, latex is styrene butadiene rubber is also used as a polymer in bitumen, and that definitely
Okay.
improves the characteristics. Yeah.
So, what are the materials used in this latex?
Latex
Like
is basically your rubber.
polymer.
Latex
Yes,
is rubber,
Rubber
styrene butadiene
Okay.
rubber.
So, sir, crumb rubber modified bitumen is crumb rubber used
No.
in crumb rubber modified bitumen?
Yeah,
Are they
that's
same or?
No. Crumb rubber is different. Crumb rubber is your
Okay.
basically wasted tires and all. Na? So
Yes,
they
yes,
take
sir.
that
I
and
used
shred
that. Yes,
they
okay.
shred that into small pieces, and that they put into the bitumen.
But that's like a filler effect also, right?
It's got a filler effect plus
Yes.
yeah, it's got more of a filler effect. Correct. But here we are talking about polymer that forms some sort of a internal structure with the bitumen. Of course, that is a very specialized question. I don't think it's within our scope of understanding to answer
you
that.
can email bitumen specialist.
Yeah, we have people who are specialists in that area. Certainly, if you.
Thank you, sir.
Yeah.
But generally, like a crumb rubber, I think it will also add a little bit of flexibility to the system.
Yes.
And but
some additives, I think, sir, special additives are added with the crumb rubber.
Crumb rubber, I don't know if it is considered as an additive.
Yeah, it is an additive, but it's not like a polymer modification of the bitumen.
Yeah. Not a chemical action, rather.
Not a chemical action.
Yeah, more of a mechanical action.
Okay.
Should we put natural bed of stones normal to the direction of load in masonry? Natural bed of stones normal to the direction of load. Well, that's how you'll be laying it, right? Because when you extract the bed stones from a natural bed, they'll be oriented in a particular direction. So when you actually cut the stones, you'll probably be extracting it in that fashion. So it'll be easier to actually make stone prisms which are along the natural bed. In any case, you can actually have systems that are also designed to load perpendicular to the natural bed direction. Again, that depends on what type of rock it is. If it's a metamorphic rock, there may be foliation. There may be like platy nature, in which case you have to be very specific about which direction you're loading it in. In most cases, you'll be loading it normal to the direction of the bed only. It won't matter in the case of granite or limestone because you don't have a problem with the foliation or platiness. But if you have metamorphic rock, you need to be careful. Other questions from people who are online?
Sir, excuse me, sir.
Yeah.
Sir, my other question is, sir, like we use, sir, like in some places, sir, we use concrete, sir, instead of bitumen, sir. Like,
Yeah.
sir, but sir, in the same time, sir, like in the winter time, sir, like due to the slippery surface, sir, due to ice and the snow, sir, they are very much slippery, sir. So a person can't walk from there, sir. Actually, I have a question, like, sir. Actually, nowadays, sir, like I have seen, like, sir, in our streets, sir, like tiles, sir, like they are putting tiles over there. So in our area, sir, like the condition is like it is too much snow, sir, actually in that area. So like due to snow, like people would get slips, sir, like it is a slippery surface, sir. So sir, what will be the idea, sir? Like what should be used instead of tiles, sir? Like people used to say, sir, like it should be not, nothing should be used like concrete or tile because it is not feasible as per our area. So, sir, it should be avoided, sir.
Rough
Like,
surface is what you want.
yes, sir. Yes, sir.
Do you have stones?
Yes, sir. Yes, sir.
So maybe just stone would be good enough, I think, with,
Or even if it's concrete, you can sprinkle some sand on the surface. That's usually used in many places to ensure that slipperiness can be avoided. Even in highways, they do that. In Western countries where the highways start icing, you can put some sand on the surface, or salts also on the surface can help reduce the formation of ice.
You are talking about a construction material, right?
Yes, sir. Yes, sir. Yes, sir.
Or you're talking about a solution after the ice is formed?
No, sir, I'm asking about a construction material, sir. Like, what should be used, sir? Like, alternative, sir. What should be used instead of that, sir? Like, instead of that concrete or that tile, sir. What should be used, sir? Like, what should be another option? Can be available or not, sir? Like, yes, sir.
Yeah, it just depends on what's available. It's I mean,
if you have rock pieces, I think that is good, but I don't know the how.
See, if it's a vehicular pavement, it has to be made. I mean, depending on the extent of traffic, it has to be made into either a asphalt concrete or cement concrete pavement. If it's a simple pedestrian walkway, then you have a choice of using, for instance, if you have stones and stuff like that, you can use that. So it all depends what material is available and what you're likely to use.
But definitely not smooth surface tiles.
Yeah. So tiles are not good.
Any other question?
Yes, sir.
Yeah.
Sir, I want to ask that after seasoning of timber, do we need to do something further to prevent biological growth while storing it for a long time?
Generally, they do some chemical treatment so that it won't decay further, and also deformations will be less. For especially when you talk about long usage. So what we do in a normal construction, because in some part of our country you may not get treated timber, right? So in such cases, what we do is we apply some either a bituminous layer or some kind of coating on the wooden surface, or wherever the wood is in contact with the soil, you apply a bituminous coating, and that will prevent the entry of further moisture and then associated decay.
Thank you, sir.
Yeah. Main idea is to prevent the or disconnect the wooden material from the soil.
So can we apply varnishes or paints to do it?
You see, those may not last very long. So that is why bituminous materials are usually preferred. But now if you look in the market, maybe there are other products, but you ask how long they will last. If somebody is trying to sell, you should ask what is the longevity of that.
Sir, actually, sir, timber, sir, like I have seen timber after some time, sir, like due to sunlight, sir, it cracks, sir, like cracks happen in the timber, in the windows, sir, due to sunlight. Is there any not prevention, sir, to prevent that window, sir, like it gets cracked after like few days, sir? Like it depends upon the quality of the wood, sir, something.
Yeah, that's why all timber are not used for construction.
Yes, sir.
So,
yes, sir.
Yeah, if crack, if it is not really highly resistant against cracking, maybe that is not a good timber for that kind of construction. So that's sometimes we also use pre-stressing, right? You compress. I think in railway sleepers and all that, sometimes they pre-stress it so that these cracks can, or the deformation after the construction can be minimized.
Yes, sir.
Yeah, but remember that all timber is not good for all applications. So you have to see what is good for construction and what is not.
Some timbers are like they take bending also, sir. After like as we keep them somewhere, sir, they get sir bend sir at some surface. So yes, when we are doing construction, it's not at the level, sir. So we have to level it again. So it's again a problem, sir.
There is one question from Sagumia Chandran. Is interlocking block applicable for higher building?
Well, generally, interlocking block masonry would be used for smaller buildings. For taller buildings, you'll go typically with framed structures, and the intermediate portion you'll probably fill it up with larger concrete blocks. But yeah, you could use interlocking block there also. But usually it's used more for ground floor construction or ground story construction.
And also, typical interlocking block will be bigger in size.
Yeah.
So, you have to think about how easy it is to construct, like carry it to a higher level. So many aspects you have to think while selecting material.
Correct.
Satyamurthy, hi sir, I have a doubt in bond, bed joint, thickness.
Is lesser grade. What will happen to related to load bearing wall? Again, as I said earlier, when you have a thick bed joint or thick mortar joint, it's not good for the strength of the wall. To make the wall stronger, you need to have a thinner joint. But as I said earlier, your thickness of the joint is dependent a lot on the sand size that you're using in the system. If you are going to be using 2.36 mm, like most people, then you can't have anything less than 10 millimeters thickness. What is the percentage of ground granulated blast furnace slag in concrete? Well, it depends on what you want to put in. You're allowed to put up to 70% as replacement of cement. Okay. Slag, you're allowed to put up to 70% as replacement of cement.
Yes, sir.
Yeah.
So it is a byproduct of iron.
Yeah, in iron and steel manufacture, you get the slag in the blast furnace process. You collect it as a molten material, then you quench it to make it into slag.
Okay, sir.
Anything else? So we can close. Okay, one more.
So it's possible timber reinforcement can be provided in precast concrete beam with proper precaution like bituminous coating or epoxy coating.
I didn't understand.
No, can you use timber reinforcement inside a precast concrete beam? If you can protect the timber, can you use it as? But why would you do that? That's the question. You would not want to make a composite out of timber and concrete. It won't be a good idea.
You also have to think the strength level of these materials.
Yeah.
They may not see if you take a timber piece, because if you want to use it in concrete, definitely you want it to have a good tensile property. And when you look at steel, tensile strength of steel and tensile strength of timber, it may be very different, right? So it may not really work out to be a good system. So
in any case, timber in protecting it in a concrete environment, ensuring that you get the right level of compatibility with the concrete, that may be difficult. Steel is much more compatible.
Sir, but the steel is very much expensive, sir. So what should be like without using steel, sir? Like in timber, also, sir. Like in a cheaper way, sir. What should?
No, why now you can also think about carbon. No, you don't want to cut trees.
Yeah, timber you're using trees. No, you're cutting trees. But with timber, why do you want to mix with concrete? If you have to make a structure, if you have timber at low cost, good quality, you may as well make a structure directly with timber.
Yes.
You don't need to mix it with concrete. There's no need.
See, dead load also will be very less, no? Because earlier before concrete, we made structures with timber only timber. Dead load will be less. So the dimensions of the elements will also come down.
Yeah.
And decrease, right?
In fact, if you go to the Western countries where it's easily available, people prefer to construct in timber because they can build their own houses. I mean, several people actually build their own houses.
Yes.
They buy timber, good quality timber from a large store, and they build their own houses. Okay.
Okay,
I
thank
think
you.
we'll close
Yeah.
with that. So thank you all very much for participating. It was
Thank you,
nice
sir.
to hear from all of you.
Thank you, sir. Thank you, sir.
And I hope that next time also we'll get you to participate and interact with such interesting questions. Yeah.
Sure.
So we'll meet same day, same date, same time next month.
Next month. Yeah.
Thank you, sir.
Okay.
Yeah.
Thank you, sir.
Okay.
Bye.
Thank you, sir.
Bye then.